Lesson 22, I will find factor pairs for numbers to 100 and define prime and composite. So in your Zern lesson today, you were reminded what the word factor means. So remember, if I have a multiplication problem like 4 times 2 equals 8, 4 and 2 are my factors, and 8 would be my product. So those are some terms that you've heard before, but maybe you haven't completely mastered what they mean. And then we're going to talk some more about prime and composite. You learned a little bit about this in your Zern lesson, but we're going to talk more about that today in your problem set. So go ahead and write your name at the top of your problem set, and then let's take a look at our directions. Record the factors of the given numbers as multiplication sentences and as a list in order from least to greatest. Classify each as prime or composite. The first problem is done for you. So here's the issue that I find with fourth graders when they're trying to identify all the factors in a number. Usually what they do is they just try to rack their brain and think of all the multiplication problems they can that make that number. Well, that's a really good strategy when you're doing numbers like 4, because there's only 2 multiplication facts that equal 4. But when we start getting into some of these bigger numbers that have 8, 9, and 10 factors, it's going to be a little tougher to not leave some out. So today I want to talk to you about a strategy that they really didn't talk to you about in Zern, but that I'd like for you to use. So the first thing I want you to do is I want you to think of the smallest number that could be a factor of 6. Well, every number has a factor of 1, right? 1 times what equals 6? Well, 1 times 6 equals 6. So 1 is the greatest factor of 6, and 1 is the smallest factor of 6, and 6 is the greatest factor. So the only other numbers that could be factors of 6 are 2, 3, 4, and 5. That's it. So let's think about 2. Is there anything times 2 that equals 6? Well, yes, 3, right? 2 times 3 equals 6. So we've got 1, 2, 3. That only leaves 4 and 5, right? So is 4 a factor of 6? Is there anything times 4 that equals 6? No. Is there anything times 5 that equals 6? No. So these are the factors of 6. So I like to list them like this. 1 is the smallest. 6 is the greatest, okay? We know that 2 is a factor. 2 times 3. Because 2 times 3 is a factor, I already know that 4 and 5 are not factors of 6, even though I already know that. But just because I'm doing this from smallest to greatest, because there's nothing in between 2 and 3 when I count, I know that I have found all the factors. So if you remember what the terms prime and composite mean, a prime number only has 2 factors. It has exactly 2. Well, because 6 has 1, 2, 3, 4, then by definition, it is composite. Okay, so let's take a look at number 7. All right, so we know that every number has a factor of 1. So 1 times 7 is a factor pair. Okay, so that means the only other factors that there could be of 7 are the numbers that come between 1 and 7, like 2, 3, 4, 5, and 6. Well, nothing times 2 equals 7. Nothing times 3 equals 7. Nothing times 4. Nothing times 5. And nothing times 6. So that means that the factors of 7 are 1 and 7. So because it has exactly 2 factors, that means that it is prime. Okay? All right, so let's take a look at the number 9. Okay? Again, the smallest factor of 9 is 1, and the largest factor of 9 is 9. So that means that the only numbers that can be factors of 9 are the numbers that come between 9, like 2, 3, 4, 5, 6, 7, and 8. So is there anything times 2 that equals 9? No. Is there anything times 3 that equals 9? Yes. 3 times 3 equals 9. Is there anything times 4? Times 5? Times 6? Times 7? Times 8? No. So these are all the factors of 9. And when you make them in a list, it's really easy to see if you got them all, because 1 is the smallest, 9 is the largest. Okay, 2 was not a factor, but 3 was a factor. And then when I put 3 over here, I have 1, 3. There's nothing in between 3. Now, because 3 is the same number, I technically don't have to list it twice. So you could just do 1, 3, oops, excuse me, 1, 3, and 9, just like that. Okay? So because it has 1, 2, 3 factors, that means that 9 is composite. All right, so I want you to try to do 12 all by yourself, and then let's come back and check together. Okay, so let's see if you found them all. All right, so first of all, you know that 1 times 12 is a factor pair. So that means that the only other factors of 12 have to come between 1 and 12. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 are the only possibilities. So after 1 is 2. So I thought to myself, is there anything times 2 that equals 12? And the answer is yes, because 2 times 6 equals 12. So then I thought, well, what about 3? Is there anything times 3 that equals 12? And the answer to that is yes. 3 times 4 equals 12. And I already used 4. Nothing times 5. I already used 6. Nothing times 7, 8, 9, or 10, or 11. So these are all the factor pairs of 12. So then I just went and ordered them from least to greatest. So I had 1, 2, 3, 4, 6, and 12. And because I had all of those factors, then 12 is composite. All right, so let's take a look at 13. I'd like for you to try to do F, G, and H all by yourself, and then we'll come back and check together. Okay, so let's see how you did. All right, so let's start up here with F. So with F, we had the number 13. So I knew that 1 times 13 was 13. So then I thought to myself, nothing times 2, nothing times 3, nothing times 4, 5, 6, 7, 8, 9, 10, 11, or 12 equals 13. So that means that is all of the factors. The factors are 1 and 13, so that means that 13 is prime. All right, let's take a look at G. So this time we had 15. So again, I knew 1 times 15 is 15. So that means all the numbers between 1 and 15 could possibly be factors. There was nothing times 2 that equals 15. However, 3 times 5 does equal 15. So then I thought to myself, nothing times 4, nothing, and I already have 5, or 6, or 7, or 8, or 9, and so on. So those are the only factors of 15. So I have 1, 3, 5, and 15, which means that 15 is composite because it has more than 2 factors. So for H, I did 16. So I knew 1 times 16 was 16. So then I had to try all the numbers between 1 and 16. So I thought to myself, is there anything times 2? And the answer is yes. 2 times 8 equals 16. So then I thought to myself, well, what about 3? And the answer is no. Well, what about 4? And I came up with 4 times 4 equals 16. None of the other numbers worked, so my factors are 1, 2, 4. I didn't put 4 twice, 8 and 16, which makes it composite. Okay? All right, I'd like for you to do the next 4 by yourself, and then let's come back and check together. Okay, so let's take a look at problem I. So we had the number 18. So obviously we're going to start with 1 times 18, which is 18. And then I thought to myself, is there anything times 2 that equals 18? And that is 2 times 9. So after 2 would be 3. So I thought, is there anything times 3 that equals 18? And I thought, yes, there is 6. So I went through all the other numbers and nothing else equaled 18. So the factors of 18 are 1, 2, 3, 6, 9, and 18. And that makes 18 composite. All right, so let's take a look at our next number, which is 19. So I thought really long and hard, and the only problem I could come up with is 1 times 19, which equals 19. So the factors of 19 are 1 and 19, which makes it prime. Okay, let's take a look at K. All right, so for K, we had 21. So I started with 1 times 21, which equals 21. Nothing times 2 equals 21, but 3 times 7 also equals 21. So my factors of 21 are 1, 3, 7, 21, which makes it composite. And then my last number was 24. So 24 had quite a few. I had 1 times 24, and then I thought, was there anything times 2? Well, yes, 2 times 12, and I thought anything times 3, and that is 3 times 8, and I thought anything times 4, and that is 4 times 6. So it had quite a few. 1, 2, 3, 4, 6, 8, 12, and 24. So it too is composite. All right, so now let's take a look at number 2. It says find all factors for the following numbers and classify each number as prime or composite. Explain your classification of each as prime or composite. Okay, so let's just do the first one together so you can kind of see what's expected. So, first of all, I know that like all the other numbers, one factor pair for 25 would be 1 and 25, right? So, I know that all the numbers between 1 and 24 could possibly be factors of 25. But there's nothing times 2, nothing times 3, nothing times 4. The only other factor that I can think of would be 5 times 5. So if I went through all the other numbers, nothing else would equal 25 except 1 times 25 and 5 times 5. So would this make 25 prime or composite? Well, it is composite, and it says that I have to explain my classification, so I'm going to explain that it has 4 factors. Because remember, prime numbers have exactly 2 factors, so anything else would make it composite. All right, I want you to try to do 28 and 29 by yourself, and then let's come back and check together. Okay, so let's take a look at our factor pairs for 28. So first of all, I thought to myself, well, I know 1 and 28 are factors, just like in 29, 1 and 29. So then I thought, well, after 1 would be 2, and I thought 2 times 14 equals 28. I knew that because it's an even number, and all even numbers have a factor of 2. Nothing times 3 equals 28, but 4 times 7 does equal 28, and nothing times 5 and nothing times 6. So 28 is composite. Again, it has 6 factors. For 29, I could only think of the 2 factors, so it is prime because it only has 2 factors. Okay, so Brian says all prime numbers are odd numbers. List all of the prime numbers less than 20 in numerical order. So first of all, the first number between 0 and 20 is 1, and 1 is neither prime nor is it composite. So let's think about the number 2. How many factors are there in the number of 2? Well, there's 1 times 2, so that means that 2 is prime because it only has 2 factors. What about 3? The only thing that equals 3 would be 1 times 3, right? What about 4? No, because 4 times 1 and 2 times 2. What about 5? Yes, 5 would be prime. What about 6? No, because 2 times 3 equals 6. I want you to keep going and think of all the prime numbers that you can between 20, and then let's come back and see if we have the same list. Okay, so for a minute I thought, well, maybe I know 2 is not odd, but I was certainly getting a lot of odd numbers. So I had 3, 5, 7, 8 is not, and then I thought 9. Well, no, 9's not prime because 3 times 3. So the next prime number I came up with was 11. And then 12 is not prime. And then I thought, well, 13 is, because the only thing I can think of for 13 is 1 times 13. 14's not prime. 15's not prime because 3 times 5 is 15. So the next one I came up with was 17. And then the last one I could come up with was 19. So use your list to show that Brian's claim is false. Brian says all prime numbers are odd numbers. Most of these are, but which one of these is not? Number 2. So we can say that 2 is prime and even. That proves that Brian is false. All right, let's take a look at number 4. So Sheila has 28 stickers to divide evenly among friends. Okay, so we're reading. She thinks there will be no leftovers. Use what you know about factor pairs to explain if Sheila is correct. So we're going to draw here. So we could draw something to show a division problem, or we could show, since it says to use factor pairs, let's go ahead and draw us a table like we had in problem number 2. And let's put 28 right here. And let's think of all the factor pairs that we can of 28. Okay? All right, so I know 1 and 28, 2 and 14. Is there anything times 3 that equals 28? No. What about 4 and 7? And that's it, right? So how does this help us to know whether or not Sheila's right? Well, what this means is if I took 28 stickers and divided them between 28 people, everybody would get one sticker and there'd be no leftovers. If I divided it between two people, everybody would get 14 stickers and there would be none left over. Or if I divided them between 14 people, everybody would get two stickers and there would be none left over. Or I could divide them between four people and everybody would get 7 stickers with none left over. Or I could divide them among 7 people and everybody would get 4 and there would be none left over. But if I divided them among 3 people, it could not work out evenly because 3 is not a factor of 28. If it were a factor, then there would be none left over, right? So if I actually divided 28 by 3, the closest I could get to 28 would be 9, because 9 times 3 is 27, and that would leave a remainder of 1. Okay, so I read the problem, I wrote a number sentence. Now I'm ready to write an answer to the question. Use what you know about factor pairs to explain if Sheila is correct. So I went ahead and wrote over here, Sheila is incorrect. 3 is not a factor of 28, so there would be a remainder. So what can we learn from that? We can learn that you can tell if a number is a factor of another number by dividing it. And if there is a remainder, then that means that that number is not a factor of the larger number. All right, so today we learned about prime and composite. Remember that prime means it has exactly 2 factors. Composite means that it has more than 2.